There are two particular forms that an integral can take, which will make it very easy to integrate. The first one looks like this, where you have a function of x raised to some power, it could be any power except for -1, multiplied by its derivative. And we can actually follow through the substitution algebraically, but once we've got this kind of general rule as to how we integrate that, then you don't have to do the substitution every time. But the substitution we're going to make is u equals f of x. That will tell us that du by dx will be the derivative of f. And then when we come to replace the dx, it will be du divided by f primed of x. So we make the substitution. The integral will become the integral of f primed of x. Now this is f of x to the power n, but f of x is u, so that's just u to the power n. And then dx is now du divided by f primed. And we can see that in this particular case, the f primes will cancel, and we're left with the simple integral u to the n du, which is of course u to the n plus 1 divided by n plus 1 plus c, provided of course that n is not -1. Okay. So if we have an integrand that looks like this, so f of x, some function of x to the power n multiplied by the derivative of that f of x, then we can just state the answer as being the f of x to the power n plus 1 divided by n plus 1. Of course, that is actually a u, so I should perhaps write that as f of x to the power of n plus 1 divided by n plus 1 plus c. Okay. The other one is exactly the same, except it's the case when n is -1. So this is true when n is not -1, but if n is -1, then we can do something very similar, and we'll end up with the answer for this one. So this is where exactly the same case as before, except now n is -1. In other words, the f of x is on the denominator of the fraction. And again, u is going to be our f of x. So when we come to differentiate, the dx will become du divided by f primed of x. Make the substitution, the integral will then become the integral of f primed of x divided by u, du divided by f primed of x. Those two again will cancel, and we're left with the integral of 1 over u du. Now we know that that is the natural log of the modulus of u plus c. So therefore that is the natural log of the bottom, or the mod of the bottom, plus an arbitrary constant. And that's the answer. So in short, if the top of the fraction is the differential of the bottom, then the integral is the natural log of the bottom plus c. Okay. So we've got 9 examples. We're going to see a mixture of these methods. So here we've got 2 sine of x times cos to the 4 of x. So we've got cos to the power 4. So if you set u to be cos of x, then when you differentiate it, it'll be the minus sign, which will cancel with that. But it's not quite the derivative, because the derivative of cos is minus sine, whereas I've got 2 sine. So what I'm going to do here is I'm just going to say that this is minus 2 times the integral of minus sine of x times cos to the power 4 of x dx. And now it is of the form that I want, case number 1, where I've got f primed of x times f of x to the power 4 in this case. So that is going to be minus 2 times the cosine to the 5 of x, all divided by 5, plus c. And you can just write the answer. Okay, you don't have to make the actual substitution, although you can if you want, but you can just write the answer because it is of that standard form. Okay, similar one here. We've got x times x squared minus 1 to the power 5. This time we can see that the multiplier at the front is going to be the derivative of the contents of the bracket. But in order to do that, I first of all need to bring a half out so that I've got a 2x there. And I'm doing this because the differential of x squared minus 1 is 2x, so I need the 2x to be there. And now it's of that form, okay, f primed of x times f of x to the power n. So that is going to be equal to the half times x squared minus 1 to the power 6 divided by 6 plus c. And of course we can neaten that up to be a 12th x squared minus 1 to the 6 plus c. And that's the answer. Now, you had already seen this one before. I actually physically made the substitution in the substitution video. But if we write this as negative, the integral of negative sine of x over the cosine of x, and I've pulled the minus out so that the top is a differential of the bottom, we've now got a situation where the top of the fraction is a differential of the bottom of the fraction, okay, perfectly. So therefore that is going to be the natural log of the mod of the bottom plus c. And then there's one final step for this one. We know that with the minus the log, the minus can come in as a power. So that's actually the natural log of 1 over cos, which is sec of x plus c. And that's how this one is commonly written. So you don't have to physically go through the process of making the substitution u equals cos of x. You can just state the answer because it is of that standard form. Example number 4. Again, it's not quite right. The top is not quite the derivative of the bottom. Okay, I need to make it a 2x. So again, I can bring a half out to make that a 2x. And you can do that. You can bring constants in and out of the integral. You cannot bring a variable in and out of the integral. So if this was a 2, for example, I couldn't put an x there and then put a 1 over x outside, because I can't pull variables through the integral symbol, but I can pull constants through the integral symbol. Okay, so I can do that. So just make sure it's a constant you're changing. Okay, now in a situation where the top is differential of the bottom, so we can say that this is a half times the natural log of the mod of the bottom, but in this case, the bottom is always positive, so I don't actually have to mod it. So it's x squared plus 1 plus c. That's the answer. Okay, you can see how quick these are becoming. Okay, again, the top is not quite the differential of the bottom, so I need to modify it slightly. The sine 3x will differentiate to 3 cos 3x, but I've also got a minus there. So what I'm going to do is I'm going to pull out a minus a third, so that the top will become minus 3 times the cosine of 3x. And the bottom is still 4 minus sine of 3x. And I do recommend writing this step down. It just really helps to visualize what you're pulling out. Okay, it's quite tricky to go from here straight to the answer and very easy to make a mistake. Now the top is the perfect differential of the bottom of the fraction. So we can say that this is going to be the natural log of the mod of the bottom. But again, similar to the previous case, the bottom can never be negative because that's always between minus 1 and 1. So the bottom is always between 3 and 5. So I can just ignore the mod symbols. And plus c. Don't forget your plus c. Okay, you can see how quick these integrals are. I like this one. This one always throws students. Just pause for a minute, see if you can have a go at this one, but it is one of the cases that we have looked at. The way to do this one is counterintuitively to rewrite it as a fraction in a fraction, and we tend to avoid doing fractions in fractions. We tend to just have one fraction, but in this case it becomes then really visual that the top is a differential of the bottom. So these are exactly the same thing. Okay, 1 over x log x is the same as 1 over x divided by log x. But now the top is a differential of the bottom because the differential of log x is 1 over x. So this is actually just the natural log of the mod of the bottom, which is the log of x plus c. The answer is the log of x. Question 7. Okay, now this one, the top cannot be made the differential of the bottom. It's not actually that second form, it's actually back to the first form again. I'm going to write this as the integral of e to the x times 1 plus e to the x to the minus 2 dx. So we can see we've got an f primed of x out here and an f of x in there. So in this situation, n is minus 2, not minus 1. So it actually fits with the first special case. So it's going to be you just apply the power rule to this. So it's going to be 1 plus e to the x to the minus 1 divided by minus 1 plus c, which we then of course could write as minus 1 plus e to the x to the minus 1 plus c. Or maybe you might prefer to write it as c subtract 1 over 1 plus e to the x. Okay. Any of those forms is fine, although maybe not that one. This one. Okay, example number 8. Very similar to tan. You've got cot of x, integral of cot of x. Well, cot is 1 over tan, but it's better written in this case as the cosine divided by the sine. And unlike tan, this is now already in the form the top is the differential of the bottom, so therefore it's just the natural log of the bottom plus a constant. There we go. Nice and straightforward. You can see how quick these are once you know that rule. And this one here again, it's not quite the top is the differential of the bottom, but if I rewrite this as the integral of x squared into x cubed plus 1 to the minus a half, I can almost make it that this is the differential of that. And in fact, if I pull out a third, and I get 3x squared into x cubed plus 1 to the minus a half, oops, missed the dx there, then we can see that we can apply the second rule, i.e. this is the differential, sorry, the first rule, this is the differential of the contents of that, and n in this case is minus a half. So that's going to be a third multiplied by, and then we're going to add 1 to the power, so that becomes x cubed plus 1 to the positive half, and then divided by the new power, so I'm dividing by a half plus c, and dividing by a half is the same as timesing by 2, so that is 2/3 times the square root of x cubed plus 1 plus c, and that's the answer. Okay, thanks for watching.